Class example 1.8.3. The volume, V, of a sphere with radius, r, is given by the formula volume equals 4/3 pi radius cubed. Now, if the volume is equaling to 425 units, we're going to try and solve for the radius. This is not necessarily applying exponent laws. Instead, this question is just looking at solving for an actual value. So a little bit different than what we've been working on so far. So I like to start by writing out the formula with no different values inputted at the beginning. Gives me a sense of, okay, so this is r is cubed. The cube only applies to the r, not the pi, not the 4/3, because it's not in a set of brackets. I know that I'm trying to solve for r, so if I'm cubing something, I might have to cube root it. Now I know that the volume is equaling to 425. That's going to equal to 4/3 pi times some radius cubed. Okay. Now, oh, that's not nice looking. Hold on. Now, if we wanted to look at this a couple of different ways, we could, we could actually rewrite this expression on this side a little bit differently. Okay, we could write, and keep the 425 where it is for now. We could actually write this as 4 pi r cubed all divided by 3. Because technically, if I had pi, I could put it over 1, and if I had r cubed, I could put it over 1, and then I have 4/3, right? And you can see that I can separate them all out. That means I can combine the 4, the pi, and the r cubed on the numerator, and the 3 times 1 times 1, which is just 3 on the denominator. So it might make it a little bit easier for us to solve. Now, what I'm looking for is I'm trying to find this value for the radius, or the r value. So what I'm going to do is I'm going to start to use inverse operations. We call them inverse or opposite operations, right? You know, if you're adding something, the opposite or inverse is going to be subtract. If you're multiplying something, the opposite of that is going to be divide, and vice versa. If we are squaring something, then the opposite is going to be square root, and we can keep going with this idea. So for us right now, what I'm going to try and do first is I'm going to try and get rid of or move over to balance out the equation, the actual 3. So I can see that I am dividing by 3. I know the opposite of dividing by 3 is multiplying by 3. So I'm going to multiply this side by 3. And to balance things out, whatever I do to one side, I have to do to the other. Now divide by 3 and multiply by 3 cancel each other out. And then I'm going to take 425 and I'm going to multiply that by 3, and I get 1,275. I'm still left with 4 times pi times r cubed. Now, again, I'm still looking to isolate or get that r by itself because I want to solve for it. And whenever we see the word solve, what we want is r, or the variable we're looking for, on one side and everything else on the other. So I'm going to keep that r there. Now, you could move the 4 and the pi at the same time. Let's just do one step at a time. Now, I can see right now that I am multiplying 4 times pi times r. So what I'm going to do right now is instead of thinking about 4 times, I want to actually do the opposite. And I know the opposite of multiplication is division, so I'm going to divide both sides by 4. Okay, now we know multiply by 4 and divide by 4 are going to cancel each other out. So I'm going to take 1,275 and I'm going to divide it by 4. It turns out to be 318. Sorry, I don't know why I wanted to do the fraction twice. 318.75. Then I'm left with pi and r cubed still on the other side. Now again, I want to get r all by itself. So you could have moved the 4 and the pi at the same time and divided both things by 4 pi if you liked. Now I'm going to divide both sides by pi because I can still see that they're being multiplied by the r, and I'm trying to get r by itself, so then the pi cancels each other out. On your calculator, there's actually a pi button. So I know that in previous years you might have used 3.14. We're now in Math 10C, and there's a pi button on your calculator. I prefer you use the pi button. It's more accurate. So if I divide by the pi, I get 101.4 6, 1, 2, 7, 6, something, something, something. Now, we know it's going to be irrational because pi is irrational, right? We know that that's the most famous irrational number there is. So instead, what we're going to do is we're just going to leave it with dot, dot, dots, or not with the dot, dot, dots right now. We'll talk about rounding in just a second. I like to keep as many decimal places as I can until the very end. Okay. So I'm still trying to get r by itself, and right now I've got r cubed. Okay, we know that squared and square root are opposite. Multiplication and addition and subtraction are opposite, but we also know cubed and cubed root are the opposite. So if I'm trying to undo a cube, we know we can cube root this. We did this quite a bit this unit. So what I'm going to do is I'm going to cube root both sides. Now the cube and the cube root cancel, we know that. And finally I'm left with r by itself, which is a good thing. So I'm going to hit math. I'm going to go down to the cube root button, and I'm going to put 101.46127.6, and I'm going to hit equals. And I end up getting 4.664088, la 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 la. Okay, so now I can see I'm trying to give an answer as to the radius. So if I say the radius of the sphere is, and now we could round a little bit. I might just put maybe 4.67. You could put 4.7. I wouldn't go so far as to 5 because that'll give you quite a different answer. So I'm going to put 4.67. And I'm going to write the word units. We weren't given units in this question, but if I don't write the word units, sometimes it makes me forget about if I do have units, maybe I should be including them.